This is PreCalc 11, Chapter 6.2. We're going to look at how to do all this in radians. So this is pi radians. This is pi over 2 radians. This is 3 pi over 2 radians. This is 0 radians, and it's also 2 pi radians. Where do we get 2 pi from? Well, all the way around the circle is 2 pi. And if we're looking at the circumference, it's 2 pi r. Since radians is a measure of the arc length, or circumference, divided by the radius, we get 2 pi. So, in quadrant 2, we have pi minus theta. In quadrant 3, we have theta plus pi. And in quadrant 4, we have 2 pi minus theta. And in quadrant 1, it's just the same. And to convert back, you still have theta equals theta prime. Theta equals pi minus theta prime. And in quadrant 3, it's pi plus theta prime. And in quadrant 4, we have 2 pi minus theta prime. Looking at our conversions for quadrant 4, we need to convert 2 radians first. So this is 300 pi over 180. Remember, we multiply by pi and divide by 180. This is 5 pi over 3. So we have 2 pi minus 5 pi over 3. And we get pi over 3 as the reference angle. Again, this is 100 pi over 180. This simplifies to 5 pi over 9. And in quadrant 2, we do pi minus 5 pi over 9. This gives us 4 pi over 9. And C's in quadrant 3. 220 pi over 180. This reduces to 11 pi over 9. Here we have 11 pi over 9 minus pi. So that's 2 pi over 9. And finally, in the first quadrant, this is easy. We have 70 pi over 180. This is 7 pi over 18. And the answer is still the same, 7 pi over 18. We don't do anything with the angle in quadrant 1. Okay, converting back to standard. We have 40 pi over 180. This is 2 pi over 9. And in quadrant 2, we do pi minus 2 pi over 9. And we get 7 pi over 9. We have 35 pi over 180. This simplifies to 7 pi over 36. And in quadrant 4, we take 2 pi minus 7 pi over 36. We have to have a common denominator, so 2 times 36 is 72. 72 minus 7 is 65 pi over 36. 65 pi over 180. This simplifies to 13 pi over 36. And in quadrant 1, we don't do anything. That's our answer. 15 pi over 180 simplifies to pi over 12. And in quadrant 2, we add this to pi. So we have 13 pi over 12. Okay, and I'm not going to rehash everything. All I'm going to do is go to the end here on our calculators. I'm going to switch the mode to radian. And I'm going to do inverse tan of 7 over 3. And we get 1.166. 1.166 radians. And in quadrant 2, we have pi minus 1.166 radians. And second pi minus second answer. And we get 1.976. 1.976 rads. So for the principal angle using radians, we have 0 is less than or equal to theta is less than 2 pi. So what does this look like? If we had pi over 4 minus pi over 4 minus pi over 4 plus 2 pi, and we get 7 pi over 4. If we had minus 8 pi over 3, we have minus 8 pi over 3 plus 2 pi. That's 6, so minus 2 pi over 3. And we still have to add another 2 pi. And again, we're adding 6, so that's 4 pi over 3. If we had 20 pi over 3, we have to do 20 pi over 3 minus 2 pi, and that's 14 pi over 3. And we have to subtract another 2 pi, but I can see that if we subtract another 2 pi, that's not enough. So let's subtract 4 pi, 14 pi over 3 minus 4 pi. So now we're subtracting 12. So 14 minus 12 is 2 pi over 3. And here, again, we can get our answer in terms of radians. So this time we need inverse sine of 0.6, and we get 0.644. 0.644 rads. So in quadrant 3, theta equals pi plus 0.644. And we get about 3.79. And for quadrant 4, we have 2 pi minus 0.644, and that is approximately 5.64. And for the last example, I'm going to bring it down here. Theta prime equals, and I'm only going to take theta prime once because it's the same for both quadrants, inverse sine 12 over 13 and we get 1.176. So for quadrant 2, theta equals pi minus 1.176, and that's approximately 1.97. And in quadrant 3, theta equals pi plus. And that's approximately 4.32. And that completes the radian lesson.